Hello, welcome back to RB CODECRUSH. Today our topic of discussion is creation and traversal of a linked list. This topic is actually divided into two parts. This video is the first part, that is, in this video we will learn how to create a linked list, and the next consecutive video is part 2 of this topic only, that will deal with traversal through a linked list and will also consist of the source code of both creation and traversal through a linked list. Okay, so let's start discussing today's topic. Today's topic is creation of linked list. Before we go to the details of how to create a linked list, first let us recall some important concepts which are very much required in a linked list. Firstly, a node. What are nodes? Let's recall our previous lecture discussion or discussion video where we have discussed what is node. Node is the elements of linked list, which is divided into two parts. The first part is known as the information part or the information field, and the second part is known as the link field or the link part. Now before we go to creation, let's make ourselves clear about what is an avail. If there is a linked list in the memory, then there are possibilities of inserting new nodes into the linked list. Hence we require some mechanism which will provide us with some unused memory spaces where the nodes should be created. Again, if we need to delete certain nodes of a linked list, then the space which are occupied by those nodes which are to be deleted are to be freed so that these spaces can be used in future. Okay, so besides a linked list in memory, there resides another list known as a free storage list. Okay, and that free storage list is also known as avail or avail list, which consists of unused memory cells. Now let's move to creation of a linked list. Over here we have step-by-step explanation, and side by side we also have an algorithm which will be explained. So what we do for creating a linked list, we create individual nodes. So before creating individual nodes, we check whether we have space in memory or not. That is checked by this condition, that is, if avail is equals to null. If avail is equals to null, then we should be sure of the fact that there is no free available space in memory. So we print overflow, that is, no more nodes can be created because we have shortage of memory space. But if avail is not equals to null, that means there is space available in the memory for creation of new nodes. After we confirm ourselves with the fact that there are unused memory cells in the memory, we follow the following steps. What are they? We use a variable known as temp. You can use other names also because it is a variable name. You can use new or whatever, but I am using temp as my variable name. This is a node type of pointer which helps us to keep track of the location of the new node. It points to the memory address where a new node has to be created. Then what we do, we copy in the information part of the node, which is written as info of temp, that is the information part of the node which is pointed out by the pointer temp. So this line or this thing means information part of the newly created node. In that we store the item of the list, and we initially set the link part of the newly created node as null. After this, there are two conditions. Either our linked list is empty, that is, we are creating a new linked list, or our linked list consists of either one or more nodes. So firstly we will see that if our linked list is empty, then what to do? How to check whether a linked list is empty or not? If the linked list is empty, then there will not be at least one node also. That means the root of the linked list will be null. It will not be pointing to any of the memory locations because there are no first node or no nodes only in the linked list. So it will consist of an invalid memory address or null. So what we do after creating the linked list, if we find that our linked list is empty, then that newly created node becomes our first node of the linked list. So the root will now consist of the address of the newly inserted node, and the address of the newly inserted node is stored in the pointer temp, as we have already discussed. And again there is another node type of pointer known as current, which in turn will also be storing the address of the newly created node. That is, it will have the same value as that of temp, and temp is that pointer which is storing the address of the newly created node. So current is a pointer variable which will help us to keep track of the currently inserted node. So if we think that our linked list is empty, this is the condition which we will follow. These two lines or these two statements are the statements which should be followed by us. So what happens? Our linked list was empty. Now it has one node. So the scenario will be similar to this. This is the root. It is pointing to the node created, and the node is also pointed out by current. See, current. That is, the currently inserted node is this. Okay. Now what happens? Now that means what? Once this condition is executed, we will not execute this condition. Again, if we want to insert another node in the linked list, first we will follow these steps, these A, B, C, 3 steps to create the new node, and we will, what we will do, D also will be followed, and after that we will check whether the root is null or not. Is our root null? No, it is pointing to one node. That means our linked list has one node. That means this condition is not satisfying, but this condition is satisfying. That is, our linked list is consisting of either one or more nodes. In this condition, our linked list is consisting of one node. Now what we will do? This node's pointer part should contain the address of the next node, and the address of the next node is being stored in temp, as we have seen in our previous steps. So link part of this current will be saving or storing the address of the new node. That in turn is stored in temp, or temp is pointing to the new node. So the scenario will be something of like this. This is root, it is pointing to current, and the current's link part is pointing to temp, or pointing to the new node pointed out by temp. Then what we will do? We have said that to keep in track the currently inserted node, we are using the current pointer. So now the currently inserted node is our this node, right? This is our currently inserted node. So now current will not point to this anymore. Current will now point directly to this node. So we are assigning current as having the same value that of temp, that is current equals to temp. Now the scenario will be like this. That is, this is root, it is pointing to one node, and that node is again pointing to the newly inserted node, and that newly inserted, currently inserted node is being pointed out by our current. Now if again we want to insert another node, again we will follow the steps A, B, C and D to create the new node. Then we will check this condition if the linked list is empty. No, our linked list is not empty. That means our root is not null. So it will not go inside this condition. It will not execute these steps. It will directly come to step number F. That is, our linked list is consisting of more than one or one node, and similar procedure will be followed. And over here there will be another node, and that node will now be pointed out by the current pointer. Okay, so over here we come to the end of the first part of our today's topic, that is creation of linked list. Now let me once show you the algorithm. It's similar to our steps followed by us just now. Just see, n is the item. We are checking that whether avail is null or not. Temp equals to avail. If temp is null, then we will print directly overflow. Otherwise, we are creating the linked list, or the nodes of the linked list rather. Info part of the node consisting of n and link part of the node consisting of null. Then we are checking that whether our linked list is empty or not. This is the condition to check whether a linked list is empty or not. Root equals to temp. If it is empty, then we will assign root equals to temp and current equals to temp to keep in track of the currently inserted node. Otherwise, if our linked list is not empty, consisting of one or more than one nodes, then we will follow these three steps. Link of current equals to temp, link of temp equals to null, and current equals to temp. That is, current is pointing to the newly inserted node. These three steps have already been explained over here, right? Over here I have already explained. Link of current, this part will consist of the address of new node in this manner, and then this newly inserted node will be pointed out by current. The same thing has been done over here, and hence this method or this procedure ends over here. Please watch the next video so that y'all can get an idea of how to traverse through a linked list, and in that video we will have the source code of both traversal and creation of linked list. Thank you for watching.